A recap on the Lazy Susan. Um, Last video I had Lazy Susan and I showed how the inner ring wouldn't rotate all the way around. I printed the Dome Gear, Dome Gear 379, I believe it's called. The one that's cut into individual pieces, 6 pieces, A through F, and they go here, and they have 6 bolt holes, and this is why the Granite Earth dome is the one that a lot of people choose, because they pre-drill it so you don't have to mess with that. So all 6 of these holes in the printed gear ring line up with the holes in the Granite Earth dome. And then these 4 on the outside, I believe, are in all Lazy Susans. I think that might be where they put the rubber feet. Because when you use a Lazy Susan, it's usually you put a piece of wood on it and it's like a rotating table or something. So it has rubber feet to keep the metal off of whatever surface you put it on, and then the other part's bolted to the piece that is going to spin. So I printed this gear and put it on, and I noticed that it's not quite fitting together there. You can see it's... And so my first thought was, oh, I gotta print this. Some people have to print these gears at like 97% of the original size, so I thought maybe that's the issue. And then I tried to spin the plastic to line up with different holes, and I noticed, oh, wait a minute, that's off center. So it's, if you notice, that centerpiece is lined up, and then you move this around, and it's not lined up anymore, and then it kind of jams and won't move anymore. So yeah, definitely think that this is out of round. These pieces here, these are called the top ring. They're in the body folder for R2D2, and they go on the top of the body, and that's what these bolt to. So I haven't, this one is not glued together. The pieces are just laid together on this because I wanted to see, you know, what the size was and everything. This likewise obviously isn't glued together. What I haven't done is done the same thing, kind of hook the dovetails together and then see if the holes line up with that. But I just wanted to show that there are numerous pieces to the Lazy Susan assembly, and it's one of the confusing parts because Lazy Susans, people buy them from different sources and they're all different thicknesses and diameters aren't quite all the same, and so it's kind of a pain in the neck. So this is the Granite Earth. This is the Michael Baddeley 379 gear ring. This is the top ring from the body files of the R2D2 build. And then the pieces that I haven't printed yet are the lower ring to the dome. So the lower ring to the dome obviously is attached to the dome, and then it goes down over the outside of this part. So that when you look at it from the side, you've got your dome, and then you've got the body. You don't see the Lazy Susan. So this is bolted to the top ring of the body. These bolts go up into your dome, and then because the way the Lazy Susan works, this piece spins independently of this piece. This piece is locked to the body. This piece is on your dome, spins in circles, and your dome spins with it. This is the motor gear. So if you were looking at this, considering, just assume that I had the body down below. This would be the way it would be bolted to the body. And then this gear with the motor is inside the body, and the gear touches this, and when the motor spins this gear, it spins the ring. So just kind of wanted to show how that works in this first of 2 videos, because like I said, it's obviously seems like this Lazy Susan is bent, and that's why it doesn't spin by hand more than about that much. Then it starts to completely lock up. So I sent an email to Granite Earth and explained the issue. Said it doesn't look like there's damage to the box, but this thing won't spin. It's obviously not round. And I said I would like to return it. My thought was that I would go with one from Amazon. There's one that, in the forums, you can look it up. There's one that's on Amazon that, with shipping, is $25 cheaper than the Granite Earth dome, and people are having pretty good luck with it. So I thought, well, I'll just return this and get that one. And it'll save me a little bit of money. But Granite Earth, less than half an hour later, to their credit, less than half an hour after sending me, or me sending them, the, hey, I want to return this thing, they sent me an email saying, we'll send you another one free of charge. So, okay, I really kind of wanted to return it, but that's all right. I'll take a chance on another one. So I got the other one yesterday, didn't have time to open it up, so I'm not going to open it up right now on camera. I'll turn it off because I don't want to cut myself. And I'll open this up and pull it out, see if it rotates, and then put that ring on it from this one, and hopefully things will all line up and spin and everything will be hunky-dory. So hang on for that. I'll stop recording and then start when I've opened this box. Okay, new Lazy Susan opened. Well, here's something that kind of proves what's going on. Here is, on the top is the new Lazy Susan, and on the bottom is the old one. Now, they're both from Granite Earth. They should both be round. They should both be the same size, right? All right, so right up here at the top, I'm pinching these together with my fingers so they are approximately at the same point. As we go around, that's all kind of not round. That's way off, seems to me. Okay, maybe I can do a better job of, no, I can't even really do a better job of getting one point lined up. Okay, here we've got fairly close to being round, and then around here, yeah, around here we're way off on the outside, and then we're off on the inside there. So that's probably the best I can manage to show here, that the old one was definitely bent. And I mean, this isn't like super thin metal, so I don't really know how that got that bent without some serious smackage on the box. Especially when, if you look at how this fits in the box, right? It's got this, it was packed the same way, the same bubble wrap, the same thin plastic bag that the Lazy Susan was in. You see there's a little bit of space in all 4 corners, so how does it get bent? It would pretty much have to take a hit, right on a corner enough to squish it down. If it got hit here, or what? Yeah, when I say corner, I mean, what do I mean? The it's a circle. It doesn't have a corner on the side of the box. Because if you hit it on the corner of the box, you've got all this room that it would compress on both sides before the thing got bent. It would have to be a severe amount of weight, you would think, on one end. And that other box just doesn't show huge crease on top or bottom that would bend that. So I don't know how it happened. If it was like that before they shipped it or not, but yeah, this is the old one, and it just, it won't spin because it's bent. So let's put that one aside. Yeah, watch me. Don't want to risk dropping one here. There's the new one. So good for Granite Earth. Good job in getting me a replacement out fairly quickly. No charge. But yeah, I don't know how that one originally got bent. So now the question is, will my printed ring fit properly? Whoops. There we go. Small tip while I'm thinking about it for people who are printing and you're trying to label parts. If you use a Sharpie, it tends to get into the plastic and kind of bleed the ink from the Sharpie out through the layer lines. It kind of looks like a fuzzy, foggy mess. Pencil. This is a mechanical pencil. Nice crisp lettering. Also, this is the bottom of the print, so it was on the print bed, so it's nice and smooth. But still, you can label parts sometimes with a pencil, and it'll turn out better than with a Sharpie, because the Sharpie will tend to bleed. Okay, again, apologies, because I am holding the camera and trying to mess around with this. Okay, that fits great. I don't have this set on a hole. Okay, there you got one of your 6 holes. There's another one. There's another one. Okay, so the holes line up. The glue joint here lines up. There's a tiny bit of wiggle, so it's not like way loose trying to pull apart. It's not way tight jammed in there. I think that's great. I think that's how it's supposed to be. Another thought, the ring here that I printed is the 379 cut version, so the one that's not made for printing all in one piece on a printer with a 500 by 500 print bed. This is made for smaller print beds. I actually printed this on my Prusa out of PLA Plus. They recommend PETG or ABS for this, but I have enough problems with PETG that I didn't want to mess with it, which it turns out is kind of worked out anyway, because I used almost all of my PETG to successfully get the parts printed for the center foot and outside foot modifications to use the Vex Robotics Omni wheels instead of building my own Omni wheels. It's pretty expensive, but it saves a ton of work. in trying to assemble the wheels that go under R2 that are made to be, well, omnidirectional, so they roll forwards, sideways, all directions. Anyway, this hole, I was originally going to say, this hole is for the slip ring. You got to transfer electricity and signals up from the body where you've got your Arduino that controls servos and lights and all that kind of thing, and you've got power from your batteries that are in the body, and you have to pass them up into the dome, and then they go into the dome for the dome lights and any servos there to make the holo projectors move, make the panels in the dome open and close. So how do you get electricity and signal from the body up into the dome and still be able to rotate the dome without the wires getting all twisted? We'll use something called a slip ring, and that fits in this hole here. And basically the wires come up and they stop at the slip ring, and then internal in the slip ring is kind of a, actually I'm making this up, but this is how I imagine it works. Inside the slip ring is like circles of a metal, and then the top of the slip ring has like sprung steel that lines up with the lower part. So when you spin the dome, it rotates, and the connections, because they're spring loaded, the connections are metal on metal, and it lets you spin the dome any direction, any amount of times, and the wires stop at the bottom of the slip ring, start again at the top of the slip ring, and a slip ring device is made to maintain electrical connectivity while it's in movement. So there are two different sizes of holes for slip rings. When I looked in the folder, the cut version of this gear file was only for this size of slip ring, which is the larger of the two. So something to note, if you're planning on using the smaller slip ring, then you'll probably have to take the single print ring file and cut it into individual pieces by yourself, or ask someone else to do it, to get the one printed with the smaller slip ring hole. So because I printed this one, I'll be using that size of slip ring to fit in there. I don't think there's anything stopping you from also modeling maybe a piece that lays on top of that with a smaller hole. So it would actually act kind of as a reinforcement across the top, or you could put it across the bottom, maybe. So it's the same width as this brace, but has the smaller size slip ring hole in it, maybe. I'm not sure. I don't really care. I'll just spend the extra. I'm assuming it's extra. I'm assuming the larger one is more expensive because it probably is larger to accommodate either larger gauge wire and or more connections from the bottom up to the top. So anyway, ending this video on the good news that I was able to get a replacement fairly quick from Granite Earth. They were nice about it, sent it out right away. And this one spins, this one is round, and my printed gear in 100% size. I did not resize this. Like I said, some people find they have to print this at 98% or 97.5% or something to fit their dome, because they're Lazy Susan, because different Lazy Susans have different thicknesses. And so this Granite Earth one ring and the Granite Earth, well, the 379 cut file in the Mark III R2D2 files from Michael Baddeley, seems like it is just the right size. And like earlier, the other thing I have to do is basically flip it upside down and assemble this on the box and see if the holes match up here, which I'm not too worried about that. I'm sure those will. This is the part that's really concerning, because as I said, this goes on the end of your motor, and when that's bolted to the Lazy Susan, your motor spins, and that's what spins the top half of that, the dome. And this is made, again, it will go like that. It'll go under that brace because the dome sits on this part and this sits on the body. So this is the actual orientation that this gear is. It's underneath. I did have enough PETG to print the motor gear out of PETG. So I'm hoping that with the motor gear printed in PETG, I think I did 0.28 resolution on this. Seems to have turned out really nice. I'm hoping that with this PETG and this PLA Plus, that's going to be fine for the amount that I'm going to be using this thing. I mean, let's be honest, this is probably going to spend the vast majority of its life as a static statue. So I think this will be fine. And again, if I wear this out, now I know, okay, I'll just print another one of these in PETG. And I know that this is the file that fits because it fits. It fits. So, good news there. Another piece of the puzzle done. So, what do I have left on R2D2 at this point? To print, we are getting down to just the really small stuff. I have, as I was saying, this is the top ring that goes on the dome, or on the body, sorry, goes on the body. The dome has a top ring on the version 2 dome that bolts to the dome, and then a lower ring that covers this Lazy Susan. So I haven't printed the lower ring because there's two different versions, one for wider Susans, and then the one that's just, I think, just called the lower ring. So I think I just used the standard lower ring for this Lazy Susan. I don't think this is considered a wider Lazy Susan. So that's going to be another, I believe it's the same as this. I believe it's 6 pieces. It might be 7, but it's probably 6. This from the Mark III body files, not the version 2. This is from the Mark III body files. And it's 5 pieces. So I think this is 6 pieces. Maybe it's only 5, I don't know. Basically, I haven't looked at it yet because I wasn't sure which one to print, wider Susan or standard. I believe it's standard, so I'll be printing the standard lower ring for the dome. And then, what else? Oh, the motor mounts. And that's just about it that I can think of. This gets bolted to a motor, and then inside the body you have to mount the motor. So there's like a piece that goes from the inside of the body out, and you bolt your motor to it. It goes out to here. I believe that it goes all the way out to the center of this piece, so I need to do that, but I think there's different ones for different motors that you get for the dome. So that's, again, I'm down to pieces that basically I needed to get a physical mechanical part before I knew which printed part to print to go with it. So the motor mount kind of depends on the motor I get, and I think it's like 5 or so pieces for that. And then, like I said, the lower ring for the dome. The dome, actually, there's 2 buttons, they call them, on the dome. They're just really small, probably 15 PLA prints. I have those two little things to do because I just keep forgetting to print them. And I think that might be it, unless I need to reprint something, because as I'm gluing things together I mess something up, or as I'm sanding things I find that a piece is out of shape and warped or doesn't fit right or something, and I decide to reprint it. I should be pretty much done with obviously the majority of the printing, so just a tiny bit left. It's starting to get a bit expensive now. The Lazy Susan, like I said, was $70 shipped. The next thing I'm going to order is the killer is the wheels. I was talking about the wheels. The wheels that go under his feet, they use something called Omni wheels because they're omnidirectional, and there's files to print your own. Recommended to print the frame pieces in PETG, and then the actual small rubber wheels that allow it to move directions other than forward and backwards. Those in a flexible filament TPU or Ninja Flex. And that just sounds like a pain in the neck. I haven't dealt with flexible filaments, so it means buying flexible filament and getting it set up on the printer, and then you print a whole bunch of these little wheels that then go into the assembly to make the larger wheel assembly for the center leg and both outer legs to make it roll. Or you can buy from Vex Robotics. People have made modifications to use their pre-built Omni wheels. So that's what I've done. I've printed the parts in PETG. For the store-bought Omni wheels, now I just have to go online and buy the Omni wheels, and the center foot, I think it's about $20 for what they call one wheel, which is actually two combined. And that gets you, if you just had one, it wouldn't, whatever. It comes two combined, and for the center wheel, you need 4 of those, and they're $20 each. And then I need a bunch of bearings, and then I need one pair of a smaller size wheel for the left and one size smaller wheel for the right of the feet. And so I think those, if the large ones are $20, those might be a little bit less. But I mean, we're talking at least that's, $100 just in the wheels, and then I need a bunch of bearings for all the wheels, and I need bolts to hold them together. And yeah, that's going to be pretty expensive. After that, let's see, after that, then it starts getting into electronics, I guess. The motor for this, then I can print the motor mount. But I might hold off on that for a while, because buying the Lazy Susan and the wheels that's enough money to spend on it for a while. Now that I'm almost done with printing, it's concentrating on starting to assemble things. It's too cold to paint and too wet in the Pacific Northwest in November now. So unless I figure out some way to paint in our garage and not make the whole house smell like spray paint, then I might literally have to wait till the spring to do painting, which is kind of sucks. But I have a ton of gluing that I can do of parts that need to be glued together, just like that one, for example. So I've got plenty of work still to do through the winter, and there's no need to rush it, I guess. So even though I'm sure once I get to the point where assemblies start getting glued and coming together, I'll be impatient to start painting and assembling the whole thing. But I will try and take my time, and so I don't end up having to redo paint and assembly if I screw something up by doing painting in high, humid, cold temperatures. So, all right, that's where I'm at. Basically, this is just kind of was supposed to be a quick, I don't know how to do quick videos. I just ramble on too long. It's supposed to be a quick video on the whole Lazy Susan issue, where the first one was obviously bent and bad, and then I got a replacement, and it is It's round, it's smooth, it looks like it lines up great, and my printing gear parts is correct, and I'm quite happy at this point about that. So that's the end of this video.